All right, here, folks. My plan is we're going to do some in-class examples from the what's going on? All right, 1 second. All right. So we're going to just go through some of these in-class examples. I'm going to ask for some volunteers to answer. You're going to volunteer like you actually know the answers. Classes are in session, guys. So I'm looking at this from the OneNote. If you have your OneNote with you and you want to follow along, we'll do that. I'm not going to do every single one of these, but these are good things to look at. Say if you wanted to review the 7.1 and 2 quiz that would be happening next class. All right, so you have a little chart here, or table of data. Wants you to make a bar graph from this, that's fine. I'm not going to ask anybody to come up and draw a bar graph right now. We're just going to talk about what it would look like and what we need to make sure we include. What do all graphs need to have? Possible? Yeah, you need some titles. Titles on your axes. Title for the chart should be in context. Ellie? That's great. Yes, 100%. What differentiates a bar graph from a histogram? Other way around. Bar graph has spaces in between the bars. Histogram, the bars are touching. They look rather similar aside. All right. So the data that's up here, we can bar graph that pretty easily, where the x-axis is just going to be the type of personal information, and the y will just be like the height of the bar. What are we going to do with? Can we do a pie chart for that? Would that be appropriate? Why or why not? It's percentages, right? What's the problem? Yeah, you'd have to find some way to like normalize this. Specifically, like why aren't those percentages adding up to 100? Excellent, yeah. It's like one person could fall into posting a photo of themselves and their school name and the city and town where they live and their email address and their cell phone number. You could hit, lots and lots of categories. So you have like no way to probably suss that out into a way that's going to make it nicely normalized, like all add up to 100, right? Okay. So next example, in the 2008-9 regular season, basketball player Dwayne Wade averaged 7.5 assists per game and 2.2 steals per game. The following pictograph displays this information. What's wrong with the graph and how can it be improved? David.
The bottom value.
Well, it's assists and steals are that's what you're comparing. So like we've labeled the x-axis as such, right? So I think the labeling's probably okay. What's wrong with that guy though?
This is a picture
Yeah. Yeah, so what's the, well, I mean, like the heights of the basketballs seem like they're right in line with 2.2 and 7.5, right? But the picture is the issue. What's the problem with the picture? Yeah, so it's misrepresentative, right? So how, like, if we look at the numbers, your assist to steal ratio, right around 3, right? How many of those little basketballs do you feel like can fit in the big basketball? What? Like 9 or 10 maybe, right? So it's like misrepresentative of what's going on. His assists are really only 3 times his steals. It looks like his assists are like 9 or 10 times his steals. Everybody kind of see what I mean there? How would you fix it? How could we fix this graph to make it more representative? Simplest fix possible would be, yeah, just turn those basketballs into bars of equal width. Problem solved, right? That's the easiest possible thing you could do. It's most common sense, right? Just get rid of the basketballs. Okay. All right. We have 2 graphs here. They're both representing the same information. What's misleading about graph 2 versus graph 1? Yeah, so the value in the second one starts at 800. Why is that misleading? Jackson? Yeah, so if I look at the first graph, it looks like job B just pays about twice as much as job 2, or job A. If I look at the second graph, it looks like job B pays 5 times as much as job A, which is not the case, right? Because you started at 800 instead of a 0. You guys kind of see that? Again, just misrepresentative. All right. Here's a kind of a question you'll definitely have to do for a future quiz or test. So you're given a 2-way table and asked to complete it. So fill in all the blanks. So there's 2 possible starting spots as far as filling in the blanks. Can someone tell me, like, the row and column of one of the possible starting places? Android and total? Yeah. That's correct. Whoa, Boise. Because if you look at the column with total in it, you have 3 of the 4 values, right? So you should definitely be able to find the third. The other possible starting spot would be sophomores and other. Again, if you look at the other row, you have 3 of the 4 values. It should be relatively easy to find the 4. Does it matter which one you'd start with? Not at all. Those are the only 2 possible starting spots. So you're looking out for, all but one of the values in a row or a column. Once you got that, you should be able to fill the rest of that stuff in. I'm just going to write in these values now, just using like basic addition and subtraction. You guys cool with what you would do once you have a starting spot? It's pretty easy, right? 4, 108, 76, 114, 91, 34, 5. All right. Part B says, how many total students have Android phones? 85, right? You just read across the Android row to the total column. That's 85. Part C, what percentage of students are seniors that use iPhones? How'd you get 26%? Good. So it says what percentage of students, so you know it's going to be out of the total number of students, are seniors and have an iPhone. So you look at the senior and iPhone cell, that was 91, so it's 91 out of 350. Part D says what percentage of juniors use other phones? And you got that by doing, good, 11 out of 114. So notice that this one is asking what percentage of juniors, so the total for juniors should be the denominator, and then your numerator is going to be the juniors that use other phones. Poor 11 juniors with their flip phone. Everybody feel okay on doing this? Again, very similar to the type of question you might be asked to do on a quiz or a test. Again, pretty easy. You just have to be able to read, right? The reading's the hard part. Oh my God, Mr. Kulik, reading. All right. So here it's asking you to make a frequency chart with groups containing scores like 5 scores like 75 to 79, and then like 80 to 84, and then 85 to 89, etc. Now, relatively easy to do that, right? What's going to be the biggest hassle? Sorting the scores out, right? So I want to show you something you can do on your calculator that can make that a little bit easier. Actually, I'm going to have to do this. And now this takes a million years. I forgot how long this stupid, I should have had this thing up and going. All right. So if you have a calculator with you and you want to follow along with what I'm doing and practice this procedure, you're welcome to do so. If not, you can sit and watch. If you want to relearn how to do this, if you're like, oh, Mr. Kulik showed me a neat trick today on the calculator, I forgot. What should you do when you get home? Watch the video, right? Yeah. All right, so what I'm going to do is I'm going to type this data set into my calculator. To type any data set into my calculator, we're going to start by going to the Stat button, which is right there next to the left-hand arrow. From the Stat menu, I'm going to pick the Edit tab and then select the Edit command. These opens up our lists on our calculator. I have L1, L2, L3, L4, L5, etc. I'm going to type in my test scores here, my data set, all into L1. So I'm just going to press 95, enter. 82, enter. Hi.
Hi.
76, enter. What is all this?
Yearbooks.
Oh, goody.
It's really heavy.
Yeah, just set it right here. I don't want it. Okay, thank you.
Yeah.
You got all the fun jobs today, huh?
Uh-huh.
Hope you brought your back brace. Lift with your legs. I was expecting more of a laugh from you guys on that. I thought that was a pretty good joke. Notice on this, when I'm typing these in, we're at the bottom where it says L1, comma 10, or parenthesis 10, that's telling you that's the 10th entry. So as you go through this, it's probably not a half bad idea to kind of check to make sure you're still on the right number. The easiest mistake you can make is that you're miscounting or you miss a value. So I'm still on. So I was entering the 10th value there when I counted, so that's good. So I'm just entering my datas in. Actually, data's already plural, right? So I'm entering my data in. There's no S. The singular for data is datum. for your grammar for today. Nobody was looking for that. All right, so I got all the values in. I'm now going to exit out of here, so I'm going to press second and quit. So that's the mode button right next to the blue one. And now what I'm going to do is press second and stat. That's opening up the list menu. From there, I'm going to go over to the OPS tab. And the command I'm looking for is the sort. So sort A is for sort ascending. Sort D is for sort descending. So I'm going to pick sort A. And I'm going to do that on that list that I just made in L1. So I'll press second and the number 1. That'll give me the L1. Close my parentheses and press enter. And now if I look at L1, I can look at it either by typing in L1 and pressing enter, or I could go back to the stat menu and look at it that way. But now all my values are sorted. So it'll be really easy for me to count my frequencies, right? Because everything's nice in a row. Also, worth noting, we could, it wants the, it's going to have a problem with that. With the ranges, you'd have to do that by hand. So if I wanted to take the frequency chart that we made, right? So we have 60 to 64, 65 to 68, etc. If I want to convert that to a relative frequency, what's the difference between frequency and relative frequency? It's a percentage. So instead of 65 to 69, instead of that having 1 for the frequency, because I just have the 68, it would be 1 out of 24 as a percentage. What should the relative frequencies all add up to? 100%. If they don't, what would have happened? You might have lost a 1/10% or something when rounded, right? So if you round down too many times or something, you could end up with 99.9 or 100.1 or 100.01, whatever. Okay. And then another bar graph. We're not going to do that. Everybody's okay, though, with relative frequency, just a percentage? And then if they ask for a cumulative frequency or a cumulative relative frequency, what is that? Well, it's adding down, right? So in the cumulative frequency, I would have 1 for the 65 to 69. And then I would have 2 in 70 to 74, because I have a 68 and that one. And then in 75 to 79, I would have 1, 2, 3, 4, 5. So I'm just totaling my frequency chart as I go. It's like a running total chart is what the cumulative is. And the same thing for a cumulative relative frequency. I'm just adding the percentages as I go. Everybody's okay? And then you could graph that again to make your cumulative relative frequency graph or relative frequency or cumulative frequency graph, those S curves, for sure. It didn't ask us to do that here, though, right? All right. Blah, 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 blah. Same problem. Not going to do it. All right. Same data set, right? Here it's asking us to find the average grade for the class using the numbers above. How would I do that? Yep, by 24. There's 24. Now, you could do that by hand. It's fine, no problem. Probably a decent chance of making a mistake, though. That's a lot of numbers to type in. Calculator can do it for you also. Would you like to know how? Yeah. So, since I've already entered the data, we already entered all this data into L1, I'm going to just press the Stat button. This time I'm going to go over to the Calc tab. and I'm going to select the one variable stat option. The frequency list are going to leave blank. We'll see when we use that in a moment. And then I'll hit calculate. On your calculator, the symbol for average is the X bar, with the bar on top. So for this problem, your average would be 86.2, rounded to 3 sig figs. Everybody's okay? All right. Now let's find the associated mid-interval values for the frequency chart. What's the mid-interval value for 65 to 69? 67, right? Just the middle value. And the next one, it would be 72, and so on and so forth, right? Everybody happy? Use your mid-interval values to approximate the mean. So what do I have to do that? Do I just add up those mid-interval values and divide by 7? No, even though several of you did that on your activity. What this is saying is you have 167, you have 172, you have 3 77s, you have 4 82s, you have 5 87s. So if you're doing it, you'd have to have like 67 plus 72 plus 77 plus 77 plus 77 plus 82 plus 82 plus 82 plus 82, and so on and so forth. Or you type this in your calculator and just do it for you. So let's see how we do that. So I'm going to go back to the stat menu. I'm going to go to the edit command. I'm going to type in 2 new lists. List 2 is going to have the mid-interval values. So 67, 72, 77, 82, 87, 92, and 97. And list 3 is going to have the frequency. So 1, 1, 3, 4, 5, 6, 4. Oops. 5, 6, 4. So here I'm using 2 lists, one for the value and then one for the frequency. Everybody good? Okay. I'm going to exit out and then go back to the stat menu, over to the calc tab, and again I'm going to pick one variable stats. This time, the list that I'm using is L2. That's where I put my mid-interval values. And those mid-interval values all have a frequency associated with them. I put those frequencies into L3. So here we will use a frequency list. And then I'll hit calculate. And here I get 86.4. Why is there a difference between our answers, our 2 means? Why is there a difference? Yeah, kind of. Can you be a little bit more specific? The mid-interval value mean is a TF. It's an approximation, so there is likely to be some difference between the actual mean and the approximated mean. If you're really interested, you could calculate a percent error on that approximation, right? Absolute value of 86.4 minus 86.2 divided by 86.2. Absolute value times 100. Probably want to use the unrounded version, actually, but either way. Is everybody okay with the calculator piece? Are we going to be able to do a mid-interval value approximation for a mean correctly on the quiz or test? Because I promise you that's coming again. Okay. Don't let me down. Same problem. We're skipping that. Here it wants us to build histograms. Again, what do I have to remember for a histogram? Bars touch and titles. Axes get titles. What would the titles be for this? What on the x-axis I should title this as? NBA team. And the y-axis would be points per game. And the overall title for my chart could be points per game for NBA teams during the 2012 to 2013 regular season. Okay? Everybody feel okay? Yeah. Charts need titles. All right. Who can describe the shape of the dot plots? When we say shape, what are the possible answers to a shape question? Symmetric? Skew right or skew left? Very good. If I look at A, the dot plot in A, what would you say that one is? I agree. Symmetrical is what I would answer for part A as well. What about for part B? Skew right. Notice the tail on the right side is longer than the tail on the left. Everybody feel good? The other, so that's just part of, what's the acronym that shape is part of? SOX, right? Shapes, outliers, center, spread is usually the criteria we use to describe a graph. So shape, skew left, right, or symmetric. Outliers, yes or no, like this value looks like it's really far away. Do you see any outliers on either of those two graphs? No, man. Everything looks pretty reasonably close to each other. Center, typically you'd answer with a mean, a median, or a mode. For a dot plot, I would use a median. You can just count to see what the median is. Right? Just count it from each end. You take the middle value or the average of the middle two values if there's an odd or even number of data in the set. And then the spread is just like the range of values. So you just take the biggest one minus the smallest one. That's a range, but that's a good number for a spread. Or you could compute a standard deviation. You don't know how to do that yet. That's coming in subsequent sections in this chapter. Okay? So shape, outliers, center, spread. That's SOX. Continuing on going, dot plot. I don't want to draw it, right? We talked about how to do this. Is everybody okay on the SOX description? Shape, center, outlier, spread. So if I were asked to compare these two distributions, what would be my vocabulary for comparison? What are those things on your feet? SOX. That's what I'm using to compare them. So the graph on top, what's the shape? Skew right, I agree. On the bottom, symmetric. Everybody agree? So that's one comparison done. Compared the shapes. Outliers. Any outliers on the top one? Yeah, those last two values at the far end there look potentially outlier to me also. How about on the bottom? Nah, man. Centers. So you could count out the actual median. I don't really need you to do that. If you were to eyeball it, the median on the top looks like it's probably 70-ish. And on the bottom, it looks like it's probably 56-ish. That's good enough, right? We just compared their centers. Everybody's okay with what I did there? Just kind of looked at, so there's about an equal number of points on either side of that number. And then the spread, let's do ranges. On top, the range looks like it's around 100. If I go from like 40 something to 150 something or so, right? So 100, 110. On bottom, the range looks like it's maybe 20 something, you know, like 40 high to 60 mid or something. So it's going to be an estimation, but that's a good comparison. We just did a great comparison. We compared the 4 key descriptors for each distribution. That's good enough. Everybody's okay? All right. Make a stem plot for just the males, and then split it for just the males. Make a key, make a stem plot that's both back-to-back and split for males and females. I'm just gonna, we're just gonna do one of these, and we're just gonna do like an abbreviated version of it. So if I look at these data sets, what should the numbers on my, does my stem have to include? So I want to locate like the smallest and largest values across both. Looks like my smallest is 153. Does anybody see a smaller one than that? Oh, there's 152, I guess. And my biggest one looks like, oh, I guess 183. Does that look right to you guys? So I'd have like male, female, and then I'll just go for my stem. I'll do 15, 16, 17, 18. So I got to have all the consecutive ones, but I'll start at 15 because I don't need anything less than that. So on the male side, now my least for 15 should be all the final digits for the 150s. What do I have to remember about those digits? We're always going small to big away from the stem, right? So I have a 1 for the 151, a 4 for the 154, a 7 for the 157, 9 for the 159. Notice I didn't use any commas. Everybody's good? Oh, it's supposed to split this though too, right? Boogers. So when you split it, you're just adding a second stem. So I would do like 0 through 4 on the first 15 and then 5 through 9 on the second 15. I'm going to stop here because quite frankly, the rest of this is like all the same. Is everybody okay? The one thing I would also need to include though is a key. The key needs to have context. So I could write like, I'll write it this way, 15/1 represents a 14-year-old student that is 151 centimeters tall. So notice that one note, you and me are gonna beef today. Okay, just like, can you just scroll down just a little bit? Okay. Oh my God, just like, let me write. notice that my key has context, right? Where did I get the context for my key? From the directions, right? It told me what kind of data this is. So 15/1 doesn't mean 151. It's representing some source of data. That 151 has a context. Where did it come from, and what does that 151 mean? It means more than like 151 means 151 centimeters. It's like, well, no, it means more than that. All right. If I want to calculate percentiles, what's the definition of a percentile? It's the number of scores worse than that divided by the total. So if I want the percentile for the Minnesota Twins, who won 66 games, I locate the 66 here, and I count 1, 2, 3 scores less than that. I think there's 30 Major League Baseball teams. I don't feel like counting them all up. I'm just going to use that. You'd want to count them. But I'm pretty sure there's 30 teams in the MLB. How about the Nationals, who won 98 games? Well, that's them. So what's their percentile going to be? $29 out of 30, right? There's 29 teams who won less games than 98, or less than 98 games. Notice, what is this saying? Can you be the 100th percentile? No, man. Like, you can't ever score the 100th percentile because you can't ever beat yourself. It's a game you cannot win. Like, your score can never be better than your own score. Oh, I know. What if you have a tie? Right? The percentile for this 93 win team doesn't matter. You just count below the 93, right? So just, or I would count above 1, 2, 3, 4, 5, 6, 7, 8. So 22 out of 30. That was easier than counting the 22. It was just counting 3 and above rather than below. Here it says sketch the cumulative relative frequency graph. I'm not going to do that right now. I'm just going to bump over to the answer key where that graph is already there. And then it asks, according to the graph, what percentage of states had median incomes below 50%? What about 55%? And then what percentage was in between? So I'm just going to cheat here a little bit because, I don't want to draw this graph. It takes a minute. Okay. So if I wanted the 50,000, that's this line right here. I trace that up. It will come out now. And then trace it over. And it looks like around the 50th percentile. Right? If you had grid lines, you could do better. I'm just guesstimating. Is everybody okay? If I do the same thing for 55, let's trace up and over. So 72, 73. Again, if you have grid lines, you can count the actual percentages. And then the difference between them, that's going to be the percent of individuals that lie in between 50 and 55,000. Everybody's okay? You can also do the reverse. Like if I say, what's the income of a state at the 80th percentile? So I can do track over and say, oh, the 80th percentile is 57,000 or something. You go both directions. You can find your quartiles doing this. So your Q0, and then Q1 is 25th percentile, and Q2 is the 50th percentile, and Q3 is the 75th, and so on and so forth. You can just kind of bang through that also. Everybody's okay? You should have done this in the homework, right? This was like the end of 7-2 homework, was building these things and using them. Should be okay with doing this. It's not hard, but like you have to know what you're looking at. And doing the same thing. And doing the same thing. I'm going to stop here. Does everybody feel okay? Again, if you don't feel good about any of these types of problems, I left a lot of stuff undone in this. Go back and try some stuff on your own. I think this is, the in-class examples are pretty good quiz review places. The answers for all the in-class examples are in the OneNote with them. They're fairly well worked out. If you've looked at them already, it's like, oh yeah, that's pretty good. Everybody good? Next up, we're going to do the 7-3. Yes, sir. Yeah, for sure. You got yourself a pass?
Yeah.
Good luck. Is it an interview?
No.
Oh, I just
I'm just interviewing this grad.
Oh, okay. Tell him I said hi.
I will.
Thanks. Everybody loves Mr. Wayne, We went to Albion together. We overlapped 1 year, but we're on the track together that 1 year. He threw the javelin. I ran in circles. Lots of them. Anyway. Section 7.3, I've divided into 2 chunks. We're going to do the center measurements today, so mean, median, mode. And then we'll do the dispersion or spread second, so ranges and quartiles and standard deviations. We'll do that next time. All right, so we've already defined what the median is, right? That's just like the middle value in our distribution. So to find that median, we can like arrange all of our observations from smallest to largest. If the number's odd, then it's just going to be the middle number. If the number of observations is even, then it's going to be the average of the middle 2 observations. Keep in mind the median value then might not be a value in the distribution. Right? If the middle 2 numbers are 68 and 67, the median is going to be 67.5. It doesn't actually have to be a value in the distribution. Everybody's okay? Have I shown you how the calculator can do that for you? All right, let's do that real quick. That was enough of a hesitation to where it's like, well, it's worth doing it again. I just want you big. All right. So I'm just going to do this for this data already in L1. I'm going to show you finding the median. And actually, I'm going to show you finding the whole 5-number summary. So Q0, Q1, Q2, Q3, Q4. Remember, Q2 is the same as the median. So to do that, all I'm going to do is I'm going to do stat, go over to calc, do the 1-variable stats. Now I need to switch that back to L1 because I had other stuff in there from before. And then hit calculate. So min x, that's Q0, that's the minimum value, that's the 68. Q1, 80.5. Notice the down arrow here. If I press down, there's some more numbers here. The median, that's Q2, 88.5. Q3, that's 91.5. Max X, that's the same thing as Q4, that's 99. Everybody cool? So again, that one variable stats button is your friend. Continue. No, we did that. All right. So again, here's a bunch of data about commute times for New York City workers. If I ask you for the median for this, that stinks, right? We're going to have to arrange that in order from smallest to biggest, and then like find the middle number or two numbers, and then, you know, like that's pretty time consuming. To do it by hand, probably the easiest way to do that would be to make a stem and leaf plot, because it's relatively easy to like get it in order from smallest to biggest that way. Once I do that, if I count from the ends, you know, like that, and then these are my middle two, which would represent 20 and 25. So I take the average of those and get 22.5 minutes. Would I ever, in practice, want to do this by hand? No, man, what am I going to do? Type this into my calculator and ask it to do it for me, right? Like, I do not have the faith in myself that I will do this without making a silly mistake. Now, can the calculator give you the wrong answer? Yeah. Why would it give you the wrong answer? You typed something in wrong. You skipped a number, you missed a digit, you typed the wrong number. The calculator's not infallible. Like, it still requires you to input the things correctly. What should you do before you hit one variable stats? Double check your list. You know, scroll through and make sure that, you know, that you typed it in correctly. It's always a real bummer to get like a whole string of questions wrong because you typed your data set in. You know, you typed 2 instead of 20 or something because it just missed the 0. Or sometimes the calculator's picky if you're going fast and you plug 2 numbers of the same digit. Try to do 22 really quick. Sometimes it doesn't catch the second 2. You know. Anyway, don't get schnookered. The next measure of center is the mean. We abbreviate the mean with the symbol x with the bar on top of it. We read that as x bar. So to find the mean, we just add up the observations and divide by the number of observations. This isn't how we're going to write our formula for the mean, though. So when I put it on a formula sheet or whatever, I'm going to use sigma notation. So that's going to include that capital Greek letter sigma. I know everyone loves saying sigma now. I don't understand. But it just like means to add them all up. So we would say that xi, or x bar, is the sum from I equals 1 to k of f sub I, that's the frequency of the ith observation, times xi, that's the ith observation, divided by n, which is just the sum of all the frequencies. I know, the notation, it's just the average, though. Like, you guys know how to do that. This is just the way we're going to write the formula for it, so that it's like, in a precise mathematical way. Will I ask you to use this one? No, man, look, we're just taking the average, right? You know how to do this, okay? It's okay. All right, so again, if we wanted to do the mean on this guy, we just add them all up and divide by the number of observations, and there we go. Notice how I showed my work for this? Did I write down every single number? No, man, I just wrote like the first couple and then did an ellipsis and had the last one. Is it okay for you to do that on your test or quiz as shown work? Absolutely. Don't waste the time writing out like 25 numbers, right? Like that stinks. Just use an ellipsis, like start out, use the ellipsis. That's your work. Type it all into your calculator. Do the one variable stats and write down the answer. Like, don't do it by hand, man. Don't write it all out. Nobody needs to see all that. Everybody's okay? All right. What do I do if I have my data given to me as a frequency chart with a frequency chart? Well, I have to do like a weighted average, right? That means I have 5 zeros, 3 ones, 3 twos, 4 threes, etc. So I have to add them all up, or I can just do the frequency times the observation and then divide by the total number of frequency. Or, what am I really going to do in practice? Type this into my calculator and have it, find the mean with a frequency list also, right? We showed you how to do that just a minute ago. Am I going to do any calculation by hand in this class? Almost never. Almost never. I'm going to have the calculator do almost everything for me. I'll write down a little bit of work to show, act like this is what I'm typing in my calculator. I'm not actually going to type it in there. I'm going to have the calculator just input the data and have the calculator do it. Yeah. Which is what the IB is expecting you to do on the exam, unlike the IBs. They're going to have the same expectation. You show a little bit of setup and then into the calculator it goes. Dave, will you prop that door? It's getting god-awful hot in here. Thank you. Appreciate it. All right. What if I'm given a set of a observation frequency chart? What if I'm giving you like a range of values in a frequency chart? How do I find the mean for something like this? Looks just like the activity we just did. What did you use? Mid-interval value. Yes, if you have ranged values and you want to do a statistic on it, the only way to work around it is to use a mid-interval value, which is just the middle value between the ends of your range. Everybody's okay? So really, this is the data that I'm entering into my calculator and then asking it to do the mean of. Or you can do it by hand. Who's got time? Now, I got better things to do. So far, so good? Okay, this is just me rehashing the steps and how to do these things on your calculator, where the one variable stats lives and stuff, how to enter data into your calculator. We did this live, so I'm just going to like buzz through all this stuff right now. Is that okay with everybody? Blah, 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 blah. Okay. The last measure of center is the mode. What is the mode again? Do you remember? Yeah, it's the most frequently occurring observation. Can there be more than one mode? Sure, if you have a tie for first place, absolutely. There can be many modes. Everybody's agreed? So like some data is bimodal, it has 2 modes, or trimodal, 3 modes, etc. Like it's fine, you can have as many modes as you want, or as like the data has, right? If you're looking at just a frequency table that has ranges on it, you don't know the individual values, right? If all you have is the ranges. But you do, so you can't find a mode. But what you can find is a modal class. Like what range of values is the most frequently occurring. So that's the only difference between mode, a single observation, modal class, like a range of values. Depending on how the information is given to you, you might be looking for a mode or a modal class. If I go back to this thing, go back. So here, you'd have a modal class. That modal class would be 10 to 14 pairs of shoes. Everybody feel okay there? Because that's the most frequency in it. If you had this graph, or this data, your mode would be 0, because 0 occurs the most times. You notice I'm just looking at the frequency to get at, right? Okay. All right, so we have these three measures of center, mean, median, mode. It's time to discuss which one to use and like, what do we have to like, or what's the relationship between them, right? So the median is most accurate in describing a skewed distribution. The mean, best for symmetric distributions without outliers. And modes are best for non-quantitative variables. Right? Like if I surveyed the class and asked everybody to pick their favorite color, I can't really take an average of colors, right? What would be the most appropriate measure for center there? Looking at the most popular color, right? Which one was the biggest response? That would be the most appropriate. As opposed to if I asked you, how many traffic tickets have you got? That makes more sense to do a mean or a median on, since it's quantitative data. Question for you guys. Let's say that I have a distribution. It looks like this. What shape is that? Skewed right. If I asked you to label where the mean, median, and mode would be on this distribution, this is how we do this. Where should the mode be? At the peak, right? Because that y-axis is really frequency. And this is like your measurement. So like, there's your mode. Now, if it's skewed right, is the median going to be pulled right or left?
Right.
Right. How much should it be pulled right? A lot or a little? A little. So we'll just draw it in and say maybe there. And the mean, will that be skewed? That'll be pulled which direction, right or left? Right. A lot or a little? More than the median, yeah. So we'll just write it that way. And the easy way to remember this is if you think about like your grades in a class, right? You take a bunch of tests. It's like, oh, I got a 90, and then a 92, and then like a 94, and like an 89, and then I got a 36. What's going to happen to your average? You're going to get crushed up because of 36, right? What's your median going to be? Still in the 90s, man. Right? Because that little 36 didn't really, like 95 and the 36, and you go to the middle, now everything is like an 89 or better. Right? Like you're still sitting pretty using a median. Is everybody cool? Blah, blah, blah. And that's kind of the end there. That's all I want to do for today. So next class, we're going to do the quiz. Where did my thingy go? If I can find my mouse. Did this to me last time. Oh, there we go. What's this say? That's why it was giving me such a hard time. Okay. So again, if you wanted to look at what was the quiz going to look like. Describe a population, given a sample, indicate quantitative or qualitative variables, construct a dot plot, calculate a mean, make a frequency chart from raw data, construct a bar graph, calculate mid-interval values, use mid-interval values to approximate the mean, complete a two-way table, Make inferences based on data. An okay inference to say is like the two things are kind of the same. There doesn't look like there's much difference, right? On your activity, most of you guys want to say like, boys or girls sent more text than the others when their data is like, yeah, it kind of looks the same to me, right? Would have been the more appropriate thing to say boys or girls sent about the same number of texts. You know, like everybody's in like the teens and 20s and 30s. It's like, I don't know, it's mostly the same. Given a measurement, use a cumulative relative frequency graph to find a percentile rank, or given the percentile rank, use a cumulative relative frequency graph to determine the measurement. So basically, this should look like those in-class examples, the 7172 homework. That's the gist of it. We'll do that next time. Depending on how long that takes, we might try to squeeze in the other half of the 7-3 notes in that day too. We'll play that by ear. The class after that, we have another activity. We're going to be doing, you guys are going to be doing mazes. Wow. So bring your maze brains, maybe sit at the kids' table next time you guys go out to eat, get the kids' menu, practice on the maze there, see if you can get like the fish to the sand castle or whatever. And then if we still have to finish up 7-3 stuff, we'll do that after the activity. We'll, at some point here before, either on the review day or snuck in one of those, we'll talk a little bit about the IA and start having you guys brainstorming for topics and doing a topic submission. We'll talk about how that'll work. That'll happen sometime when we find some time, and I only need like 10 or 15 minutes to kind of talk about that. But we'll get that going. But and then it's going to be test time. So we're almost finished the content. We just have some more practice. I have a second quiz for this chapter that I think we'll do as like an in-class open book, like partner thing or something. Just it's mostly calculator stuff, so I kind of want you to work through it. You know, be like a little thing. It'll be some easy quiz points. It's only 20 points or whatever, so like, figure that's a good payback for the matching quiz, or the vocab quiz, which everybody kind of did a bad job on. Not everybody, but like a lot of us did a real bad job on that, so there's like a little bit of me paying back, give you something easy to, get some quiz points back in the right direction there for you. But that's kind of the gist of it. It'll be test time before you know it. But nothing this week, test-wise. We have a quiz next time over this stuff, but notice that, like, it's not a lot of, like, calculation. You just have to know how to do stuff, like what stuff means. Because all the hows is really easy, right? None of the how is hard. Like, knowing what to do, that's probably the hardest part. And remembering, like, the details. But, calculator handle most of the heavy lifting for you. You just have to know what to ask it to do. All right, I'm done. You guys can chill out.